He's got 10 years of experience in product design, prototyping, electromechanical engineering, and design for manufacturing. Coming to us from Touchstone 3D, please welcome to the stage, Sam Feltz.
Hey everybody, can you hear me okay? Thank you, sir. All right. So I am here to talk to you guys today about the role of 3D modeling in product development. Again, my name is Sam. I'm the head of product development at Touchstone 3D. I've got 10-ish years of experience designing products. My background is in industrial design, or you might hear that called product design. And when I'm not working, I'm usually working on something at the house, traveling with my wife, or watching some Marvel movies. So at Touchstone, we help entrepreneurs, small businesses, medium-sized businesses take their ideas, might be a napkin sketch, maybe they've got an early prototype, all the way through the development process from concept to commercialization. It's almost always physical product. So that's kind of in a gist what we do. But today, we're going to talk about 3D modeling, and for the purposes of this conversation, I'm going to call it CAD modeling, because that's what we call it at our office. I don't want to trip over my words too much. CAD modeling is a tool that we use to visualize all of our ideas, kind of like sketching, but it allows us to do it as data. And because we can do that, it allows us to design more complex, more precisely, and it allows us to design faster than we used to be able to. One of the great things about CAD and CAD programs today is that most of them are pretty readily available and affordable. So anybody who's trying to get into product development and has the willingness to learn how to use it is able to do so. And for today, we could dive really deeply into it, but I want to talk about what you can get out of using CAD. So when you're looking for different programs, there's a lot of them out there. They all have different strengths and weaknesses. So it's important to find one that is appropriate for both your project type and also your budget. Some of them are free. Some of them cost $10,000 a year. Just depends on what you need. There's kind of two main categories of modeling that we use. The first one I'll talk about is called sub-D modeling. It's kind of similar. You might also hear a term called NURBS modeling. But this is really great for modeling organic and complex surfaces. These usually have a push-pull interface, which is really fun to use. It's fairly low precision, but it's really fast for making complex objects. The next type is called parametric modeling. And when we do this, we're using features and sketches and constrained geometry to create very specific and precise features. All of this gets rolled up in what's called a feature tree, and you can see that down at the bottom there. So let's say I need to adjust a dimension on a cut that I made. I can roll back in my tree, make that change, and roll it all forward. I don't have to start over. Everything should rebuild very nicely. So usually we end up having to combine both of these methods to end up with something that's both aesthetically appealing and also going to be manufacturable, have the precision for manufacturing. So how do we get started? Like I said earlier, usually our customers come to us and they're bringing us kind of a napkin sketch idea. I had this inspiration, maybe a technology, but I need to turn this into a product. So we help them through some market research, and then kind of help them visualize different implementations. Here's how your product could exist, maybe to meet different business objectives. And from there, we choose one and we start refining it in CAD. We take that sketch, get it into 3D, and this allows us to iterate. We can focus on things like different user touch points. If there's electronics involved, we can make sure all of our components fit, or we can tell the engineers, like, oh, you need to make your PCB half the size. And then also we can start working through the manufacturing strategy for all the different components. And I want everybody to think of CAD as a virtual blueprint. We're going to push data into the system, and it's going to let us get out a lot of cool things. It's going to get us our production data. We'll be able to do renderings and prototyping. So when you do start prototyping, you're going to start exporting your models to different techniques like 3D printing, CNC machining, maybe urethane casting. And at Touchstone, we are actually able to fabricate these and iterate almost overnight. So these technologies let you move really, really quickly and make changes on the fly. There are a lot of different fabrication methods. I mentioned 3 of them. There's probably 20, 30 different methods. All of them have different levels of quality. All of them have different cost requirements. And all of them are going to require small modifications to your CAD data in order to produce whatever that part is. When you are interested in finding the right look for your product, we like to combine the CAD modeling software with photo rendering software. It's a really quick way of trying out different shapes, different colors, different materials, different textures, without having to invest time and money into building physical prototypes. And then from there, once you've got the design you like, you can start creating higher quality renderings and animations. It's really great for advertising, marketing pitches, websites, all of the above. And I really prefer to combine renderings with photographs. I think it's a really quick way of bringing a level of kind of realism and context to the design that you're working on for your audience. As you are refining for manufacturing and trying to get your engineering work done, you can run your parts through different simulations. So that might be things like molding parameters. Is the liquid resin going to fill the mold all the way? Are you going to end up with giant sink marks, which you can talk to me later if you want to know what that is. Doing thermal analysis and applying different mechanical stresses. And we do all of this so that we feel better when we go to manufacturing that the design is going to work as we intended. When you're getting ready to release, you're going to need a way to tell your manufacturer how to make your parts. So you can work from your CAD data. You can pull dimension drawings. So you can call out critical features, critical dimensions, what materials, what colors, basically all of the instructions. You can convey your design intent to the manufacturer so they make the parts the way you want. In the past, somebody would have to sit there almost by hand and draw each of those views, which would take a long time. It would probably take me 10 minutes to make one of those drawings versus days. So it's a huge, huge increase in speed. And then last, we always make sure to give our manufacturers assembly instructions. We can export those same views of our product from the CAD model directly and explain to them, here's how we want the product assembled. This is going to help improve yield, and it's going to help improve quality control, which in the end is going to save you money. So this is not industry specific. If you have the right design process and the right CAD tools and knowledge of how to use them, you can do product development and really accelerate your product development in pretty much any industry, from medical devices to sporting goods, pretty much all of the above. Thank you.
All right. We're learning how to take ideas from digital to physical with Sam Phillips. If you have a question about CAD, how you can take something from an idea to manufacturing, please raise your hand. Note, we do have swag bags tonight. They are delightful fanny packs for those of us who remember the 80s, filled with all the summer essentials you'll need to get your time started. So, first question of the evening.
Hi, I was wondering if you could speak to how you work with clients and their ideas. So, for instance, if someone brings an idea to you, what kind of controls do you have in place, like around patents, or if it's a new idea, like what controls do you have so that they can ensure that it moves production from them?
Yeah, so we've built a kind of three-phase design, develop, deploy process. But as far as intellectual property is concerned, we always work with customers kind of in that first slide we were talking about. They brought in a napkin sketch. We're going to show them 3 different designs. All of those are going to have kind of different pros and cons. Some might have more intellectual property, some might have less, but be more affordable. So we try to work through the design before we get too far into the CAD model. You know, it's a very iterative process, but we try to tackle that early on so that we've got kind of a mutual vision of what we're trying to make.
All right, next question is coming to you, Sam, from your right over here on the couch.
Wonderful talk. What software would you recommend for a beginner trying to get a minimum viable product to 3D printing?
That's a good question. We're a big fan of Fusion 360. It's an Autodesk product. It has probably 80 to 90% of the features of something more sophisticated like SolidWorks. But SolidWorks is going to cost you $5,000, and you can get Fusion 360 for like $60 a month. So it's a good starting point. If you're doing more sophisticated like automotive engineering, it's probably not right for you. But if you're trying to make more simple products, you know, we can do everything we need to do with it. So I'd say that's probably a good starting point.
All right, next question is coming to you from center back of the room here.
So I was one of the tech shop guys that I was sad to see that go, but if there's not a makerspace available, are there ways to export CAD content that's created so that you can be a DIY person and have a physical thing, even if you don't invest in the, you know, equipment that's getting cheaper, but still costs a lot to have available?
Yeah, good question. So there are outfits like ours that do design and have 3D printers, urethane casting, laser cutting, all of that. You can also find online resources like a Proto Labs or an Exometry, where basically you upload your data, your file, and they're going to produce it exactly as you made it. So if you're feeling really confident in what you're ordering, then I would say go for it. If you feel like you need some guidance from somebody who does this regularly, I would say you would want to reach out to like a local design firm that can provide that feedback back. Like, what do you want to do with this? Oh, well, you should really make it this way.
And our next question is coming to you from the center aisle here.
Do you end up designing differently when you're working on something that needs to be reworked or repaired? And are you able to export kind of repair instructions as well as the initial manufacturing instructions?
Yeah, so I'm actually going through this right now. I had a discussion with a designer today on why we're not going to use glue. We try really hard not to use glue. OSHA doesn't like glue. But yes, we do often, especially if we're doing things that are more like instrumentation or like surgical simulators, we'll include extra parts, and then in kind of the same way we made those assembly instructions for the manufacturer, we'll make similar kind of IKEA-like guides for technicians or for the customer to swap out those specific parts. Because sometimes you know like where your failure points are going to be, and it's anticipated, the customer knows it, here's how you swap those.
Got time for one more question coming to you from your right here.
So on the multiple outputs from a single input, do you get product metrics like weight or bill of materials?
Yes, so when we build our CAD models, usually the CAD software has kind of like a materials library. So I can tell it that this solid body is steel. Okay, what's its weight? I can change that to make it nylon or polycarbonate or fabric. And if they don't have the material I need, I can usually make my own material if I know the properties. Yeah.
All right, give it up for Sam Feltz.